Hello everyone, and welcome to this three-part video series on IIS 7.5, Internet Information Services Architecture. My name is Paul Kotruba and I'm an escalation engineer with Microsoft on the ASP.NET team. And you can find out more about me on http://link2.me/about.pcociuba. This is my website on which you can find plenty of other IIS and ASP.NET related bookmarks. So, without further ado, let's start. Today's video is aimed at giving you an overall view of the components of the IIS web server. And this is the server that comes with both Windows 2008 and Windows 2008 R2 operating systems, or Windows 7 on the client. Today's demos will be done on a Windows 2008 server I have on hand, and the idea behind these clips is to try and get everybody on the same page with the bits and pieces that are actually inside an IIS server and what their role is. So let's jump into the architecture diagram and have a look at what the components of an IIS server are. Basically, these components are divided into two big groups. There is one group of components that is in the kernel mode of the OS, or built into the Windows operating system. This comes with every Windows operating system starting from Windows 2003 onwards. So you can find them in Windows 2008, 2008 R2, and Windows 7. And then there are the user mode components, which are incarnated in services and processes, which you can see in the task manager. So if we start by looking at the kernel mode components, these components are located on top of the TCP/IP stack, so they communicate directly with the TCP and IP drivers in Windows. And there is a driver called HTTP/sys, which is the HTTP driver for IIS. The main purpose of this driver is to listen for all HTTP traffic on the TCP kernel driver, and then make sure that the incoming HTTP traffic is valid. And this is why we have an HTTP listener, which actually goes ahead and validates all incoming traffic. Now, before going on, I would like to show you where you can see this driver. So let's jump into the Windows 2008 machine I have on hand. And if we look into the server manager and into the device manager of the server manager, there you will notice that I have something called non-plug and play drivers. And this you can bring up by going into the view menu and then saying show hidden devices. And in these non-plug and play drivers, among them you have the HTTP driver. So this comes built in with Windows, and it comes in with several APIs that you can use, including managed APIs, so you can actually make your own web server without installing IIS. On the user mode components, we can find the inetinfo.exe process, which is a remnant of the IIS 6 server. Inside this process, if you set up the components, you will find the SMTP service, the FTP service, which is the FTP6 from the server dating from Windows 2003, and we used to find the NMTP service in IIS 6, which has now been removed. This process also hosts the IIS admin service, which is a legacy service, and this service only serves one purpose, that is to load the IIS metabase into memory. Now, the IIS metabase was a file we used to configure the IIS 6 Windows 2003 server. It described all of the sites and the application pools that were configured on the server. You will no longer have a inetinfo.exe process if you do not install what is called the compatibility components, or the legacy components. So let's just go into the server manager, and let me show you in the web server role. If we go into add role services, you can see here that in this case I have not installed IIS 6 management compatibility. So if I look into my task manager, you will see that I do not have any inetinfo.exe process running. That's because I don't have an IIS admin service, and I don't have an SMTP or FTP service running. So moving back to the architecture diagram, let's now look at the other services that are actually running on in the user mode components of IIS. So until now, all the services that run in inet info exe don't use the HTTP sys kernel driver. And there are two services which run inside an SVC host exe process. And these are the Windows Process Activation Service, or WAS for short, and the World Wide Web Publishing Service, or W3SVC, which some of you should know from the IIS6 server. Now, both of these services run in the same SVC host exe process. And let me just show you that. And the easiest way to see that is to bring up a task manager and type in task list -svc, and this will show you all of the services that are running in SVC processes on your computer. And there you go, the SVC process with PID 300 is hosting both W3SVC and WAS inside. So what is the purpose of these two services that are hosted inside SVC host? Well, they they read in the configuration, which is now located in application host.config, which is an XML file, and this file is portrayed as not belonging to either the SVC host, which hosts WAS and W3SVC, nor inet info exe, because the configuration is read on demand. So we only read the sections we need, and we'll read them as many times as we'll need them, compared to the IIS metabase, which was read into memory at when the IIS server started, and all changes were operated on the in-memory copy. In IIS7, all changes to the configuration are operated directly on the disk copy of the file, and the two services, WAS and W3SVC, are immediately notified when a change takes place. So the www service talks to the HTTP kernel driver via the HTTP sys APIs after having read from the application host.config file, it will go and configure HTTP sys to listen on all the IP and ports on which sites in IIS are configured. So let me just show you an example of that. If we bring up the IIS Manager console, I have several sites configured on my server. So you can see the default site is now running on port 80 on all addresses, but for example, the session demo website is running on port 81. So when the server started, W3SVC configured HTTP sys to listen on all IP addresses on port 80 and 81 for these websites. Now, WAS will actually handle all of the logistics needed to get the code for the websites which are in these the web applications which are in these websites running. So these are run in what are called application pools, and an application pool, you can think about it as a logical unit of execution. And basically an application pool is something you put code in to have it execute if you're a web application. And normally web application pools correspond to one worker process, or W3WP exe. But there are some cases in which, like for example for application pool 3, you can have several W3WP instances corresponding to the same pool. This is called web gardening, and it allows multiple instances of the same application to run in side by side in case we do not have enough resources in one process to run that application. And we'll come back to this later in a later video. So inside these W3WP processes which run the code of the web applications which are inside application pools, we can have managed modules, we can have native modules, ISAPI extensions, and ISAPI filters. And in the second video, I'll go ahead and I'll explain in more detail the intricacies of how these processes execute requests. But for now, let's look at how request processing is done through all of the architecture components that are on the diagram. So first of all, a request comes in through the TCP/IP protocol layer, and the HTTP listener will go ahead and will validate that the request actually is a valid request. It will then go ahead and place it into one of the kernel request queues, which is corresponding to an application pool. So here we have a request queue which is corresponding to app pool 1, app pool 2, and app pool 3, and so on. Now, if no W3WP process is actually running for that application pool, the Windows Activation Service, or WAS, will go ahead and will start a process up for us whenever a request is placed into the queue. So let me just go ahead and illustrate that for you. So if I go and I look on my Windows 2008 server, you can see in the task manager that I don't have any W3WP processes running. But if I do fire up a Internet Explorer and I go to whack localhost and I just hit port 80, you will see that I will have a new W3WP exe process instance that will start up, and I will get a website here. So what happened was that HTTP sys notified WAS that there is no process running for application pool default app pool, and there are requests that are currently queued for that pool. So WAS actually started an instance of that pool, a W3WP exe process. Now, the other thing that can happen, so once the request is executed, we will also put it into, in case it is cacheable, we can also put it into the kernel cache of IIS. So now let's go and look at what happens when we run a request. So it comes in through the TCP/IP protocol layer, it goes through the HTTP listener to be validated, it will get queued in a request queue, it will then get picked up by one of the application pools, get executed, go through the output cache, and then get transmitted over the network to the client. And if something were to happen during execution and the process was to crash, the Windows Activation Service will automatically detect this through a pinging mechanism and will automatically relaunch another W3WP exe instance, which is called fault tolerance, so that we can continue execution. Obviously, all application data will be lost with the old process, but at least the new requests will not get cancelled directly, but will have a chance to execute on a new application instance. So there you go. This is the architecture diagram and the layout of the main components of an IIS 7 or 7.5 web server. I hope this video was, you found this video interesting, and I hope that you come back and have a look at the other videos in this series. Thank you.